with about 460 Celsius and pressure of 93 bars. Venus, the Earth's evil twin, becomes a total mystery to us, despite having a similar size and composition to Earth. And after many attempts to know more about it, we have only barely scratched the surface. And after more than 30 years of not visiting Venus, NASA is sending Da Vinci and Veritas to reveal its mysteries, so that we could know which exoplanet could potentially harbor life. After the last successful exploration that lasted for only 127 minutes, NASA have developed a new rover that can withstand this hellish environment. However, we need to create a power source system that can provide it the required energy for the longest possible period under these unforgiving conditions. In the past few years, star systems have been widely developed to maintain the green energy revolution, which opens a lot of choices to make the perfect star system for this mission. Today's most common batteries technology is the lithium-ion batteries because it has very high potential and capacity. Unfortunately, it can't withstand Venus's environment and it can cause very powerful explosions. But there's a good news. There were star systems that can operate in high temperature and pressure. It's called liquid metal batteries. It operates within 500 Celsius, and because of the ceramic cover and stainless steel coating, it can bear the high pressure in Venus. Liquid metal batteries is a chemical battery that follows the redox reaction principle, but in liquid form to avoid any distortions that happen after several charge and discharge cycles, resulting in a long life battery. Liquid metal batteries consist of 3 liquid layers, 2 liquid metal electrodes separated by a molten salt electrolyte that acts as separator solution, and because of the different densities of the 3 liquids, not mixing is happening. Comparing the different reduction and oxidation properties, we found that calcium will act as perfect donor atom along with antimony as an acceptor atom. Though calcium has a very high melting point and it's highly soluble in its salts. Thus, we are using calcium magnesium alloy to act as our cathode. This will lead to a lower melting point and solubility of calcium, but unfortunately it will decrease the potential difference. Even so, it's still in the acceptable range. Despite its outstanding characteristics, liquid metal batteries has some drawbacks, but applying metal organic framework as electrolyte will result in overcoming them. Metal organic frameworks are a class of compound consisting of metal ions or clusters coordinated to organic ligands to form 1, 2, or 3-dimensional structures, such as stable, large capacitance, acceptable voltage per cell, low response time, and strong battery will be perfect for this mission.